Hello to all dear friends. In this session we are going to cover dynamic blocks or advanced dynamic blocks. These are topics that are usually discussed at the advanced level of AutoCAD, and they're a bit more difficult and complex than other topics in AutoCAD. With the method that I will teach you over the next few sessions, you don't need to worry at all. By going through numerous examples, we will examine all the features of dynamic blocks together, and learning it will become very easy and enjoyable for you. Well, if you remember, we could use the B-enter command from the block definition menu, we could define a series of blocks for ourselves or turn existing objects in the scene into blocks, which had many advantages for us. We could bring them into our plan. We could duplicate them in different directions and use them. For example, in a hotel with 100 bedrooms, if we wanted to place 100 beds, in each of the rooms, and then for any reason, if we wanted to make a change to any of the bed objects, if they were all blocks, meaning in other words, if they were all linked together, we could, by changing one of the blocks, apply that change to all of them, which completely maps this. We learned how to create a block and to some extent, how to make changes to it. Now imagine if we had smart blocks, meaning they could adapt themselves to our needs depending on the situation. Adapt themselves. How? I'll show you with an example. Besides the fact that we can create smart blocks ourselves or create dynamic blocks, we can also go to the View Tool Palettes tab, which has various menus, and see a set of ready-made blocks there and use them. These are available in imperial and metric units. For example, I select a door object. Anywhere you see this symbol, whether it's a swing or a leaf. This means that we have a dynamic block. I select the door and place it here. Alright, I'll close this as well. This is a dynamic block. How? When I select it, I can resize its dimensions. It's 750 millimeters now. Here, it's 750 millimeters, or 75 centimeters, 80 centimeters, 90 centimeters, 100 centimeters, or 1 meter. I can only scale this to certain specific dimensions and sizes. Now it also has 60 centimeters. That's a really great feature. The standard doors we usually have range from 60 centimeters up to 1 meter. Of course, there are larger ones too, but room doors are usually at most 1 meter. Instead of scaling this myself or having to use the scale command, set a base point, and adjust it relative to my object, then go and scale it, I can easily move it with just one button. Because it's a smart block, I can flip its orientation. Actually, you see? Or even from left to right, whether I want the door to open to the left or to the right. I can change its direction, or I can even have different shapes altogether. Maybe in one place I want it like this. For example, I might want to use a 45-degree door. Here it's set to 30 degrees. I can make it 45 degrees, 60 degrees, or 90 degrees. See, all of these are within a single block. I no longer have to insert a separate block for each of these needs. I just insert it once and it covers all my requirements. Now this block is a very simple one. I'll show you how to create a block with exactly your own specifications, depending on your own taste and needs, so it will have your personal touch and you can use it in all your projects. Let's also look at some other examples together. You can have an aluminum window in your project, and this one is dynamic, meaning you can increase or decrease its length based on certain standards from both directions. Or for example, here you have a toilet. It's a Western style toilet that you can view from the front elevation, from the plan, that is from above, and from the side, unlike a regular toilet. Previously we had to import 3 separate objects, but now if we need such an object for different requirements, we just import it once here. We can get all 3 views from it. Its orientation can also be changed very easily. Again, there are different models. Here's another model of a Western-style toilet, a different version. From the front, with the flush tank and siphon visible, so you have the front view, the plan view, and the side view. In the same way for other objects that we have, like for example a typical car. Here we have a dynamic block and we're viewing it from the side, providing a clear perspective. From above, the top view, the plan, and the front view. The tree object is the same way. We have the tree from the plan or top view, from the front view, and now different types of trees from the plan and from the front. What is a tree? Well, it can often be useful in our projects. There is the architecture section, the mechanical, electrical, civil, and road construction sections, and the structural section. For example, I can have an I-beam, which is really useful for structural drafting. These I-beams, according to the standards available in the market, come in various sizes and dimensions, and their flange and web proportions differ, or in other words, they have different shapes and sizes. You can select them based on their exact size from among the dynamic blocks. This was just a part of the features that come with AutoCAD's ready-made advanced dynamic blocks. Here, in this session and the upcoming ones, we'll teach you how to create your own blocks from scratch. Dynamic blocks that you can customize according to your needs, in different situations. You can use them in many ways, and they really help increase your work speed. A project, you can wrap up a project very quickly, and this can really help you earn more or boost your credibility and skills. So I've brought a few examples here. Some ready-made blocks that are very simple, meaning they're just objects that have been drawn. You've learned how to turn these into blocks in previous sessions. These are simple blocks, as you can see. We can only move them around. They don't have any other options or features. If we want to access the dynamic blocks section, we need to enter the block editor. That's where we create dynamic blocks. Or, for smart and advanced blocks, how do we do this? We either select the block and double click on it. Whichever block you want, let's say this table block is fine, I select it and enter the block editor window. You see the block editor tab has opened here as a contextual ribbon or a temporary ribbon. I can access various options, edit it, create an advanced or dynamic block, and basically do whatever I want. What's the other method? The alternative approach? I simply press the BE block editor shortcut key, then click, and carefully select the other object that I want to work with. Again, I get access to the block editor window. And there's yet another way as well. On the Insert tab, here is the option. We click on Block Editor. Again, we select our block and it enters the block editor window. For example, I select this table, double click on it, and it automatically shows its name here as Table ZO2. I click OK and it enters the block editor window. In this window, the objects are now seen as separate from each other. You can see it. I can also select each one separately if I want. Now, this block editor window has different sections. The first section is the Edit Block option, which, when clicked, closes the current block. Now, it either saves the changes we've made or discards them, meaning it doesn't apply the changes. The Exist Block Definition window. Does it actually open? I can then select another object and subsequently enter the block editor window once again. Save Block saves the changes we make to the block. Test Block, when we click on it, takes our object into a window where I have access to all the tabs, just like the normal AutoCAD mode. But it's only for testing the block, because smart blocks are a bit complex and advanced, so every item we add to them needs to be tested first. We need to see if it works correctly or not, especially if it has several complex items. Then, if everything is okay, we come here and click on Close Test Block. Our test window closes, and once our test is done, we come back to the block editor if we want to exit. Again, we click on Close Block Editor. It saves and exits. The next section we have are the next two panels, Geometric Bits and Dimensioning, which we reviewed together in the previous session. Other options we have here are new in the Manage panel. We can delete the constraints we've set. For example, I set a constraint. I set a dimension here. I can select it and delete it. I can have guides just for construction purposes. For example, look, I create a line here, for instance. This line is just so, for example, it can be the axis of symmetry for this table, and it's not supposed to be printed or seen later, and I myself want to know that this is a guide or auxiliary line, so I select it. I say, in the block editor window, I click on construction. It asks if it should be converted to a guideline, and I say yes. You can see now its appearance is completely different. I can also resize it, make it bigger so you can see it better. You see it has become a dashed line, a faint dashed line that is just my guide or reference line. And I can also delete it. We've already reviewed the Parameters Manager, so you know how it works. The authoring palettes are the same palettes that appear here for parameters, actions, parameter sets, and gates. We have gates that are accessible from this section, and we also have parameters and actions here. These are specifically for creating dynamic blocks. I'll explain it to you in detail, and you're already familiar with attributes or tag labels. We have the visibility section, which relates to the visibility parameter here, and then there's close block editor. Were you familiar with most of these options? It's just now the action parameters and visibility sections. Exactly, now we want to go through all the menus that are here. We'll review them together in this session and the upcoming sessions. So, as you can see, to create a dynamic block, we need to assign a set of parameters and actions. A parameter, as its name suggests, simply assigns a parameter, a label, or a position to an object. Then, for that object to have the necessary functionality, to have a function, or to be able to perform an operation on it, like that door we were able to move. Rotate it 30 or 90 degrees, or make it bigger or smaller, or turn it into a left or right opening. These all require actions to be assigned to them, so parameters without actions are meaningless. Now let's go through them one by one. We have the point parameter. I can assign a point to this object as well. It can be anywhere. It can even be outside the object. Here, I'm turning off the 8th hub. This yellow exclamation mark that appears next to the point means that it's just an empty parameter and no action has been assigned to it. If I close the block editor and save, this is my object. If I move it lower to separate it from the other space, you'll see that neither the point parameter is there, nor can I do anything special with it. Nothing has changed. I'll go back into the block editor window, so I need to assign an action to it. How do I know which action I can assign to this point parameter? Again, I click on this parameter, which is marked as position. Here, either in this menu or down here, it tells me I can assign move or stretch actions to it. Look, if I go to the actions, I can assign move and stretch, for example, scale. I can't assign rotate or flip and the like, only move and stretch. Now I can either select from here or exit the command and say I want to assign the move action. It asks, to which parameter do you want to assign it on the object? I say to this parameter that I defined, and I click this bottom part. Then it asks, select objects. Select the objects you want. I select these objects and press enter, meaning my work is done. The warning sign is gone and the move action has appeared next to this parameter. Now I save, and when I select the object, this point also appears. Next to it is my point parameter, which has now appeared and is doing something. I can use this point as a grip. I can move it, reposition it. You see, this point that remains is now the base point of our block. Very easily we created a simple dynamic or smart block. Why is it smart? Because it asks, is it on this level now? Its smartness is very simple. It just has a grip that we can move. If there was no grip, what would we have to do? We said move, select object, enter, base point, let's say here, and then change it. And from here on, we'd have to keep doing the same thing. But now it has a grip, so it's easy. We enter the block editor window again. We can do it. If we close this, it disappears. If we click on it again, it reappears here, or we can right click. You can delete it with delete. You mean it's completely gone, right? Not just hidden from us, but actually deleted? We can come to the selection, our object that we had selected. We can either select new objects or modify and edit them. For example, if we bring in these two chairs, we can rename our action. Instead of move, we can give it another name and we can choose to show all actions or hide them. Now suppose I want to be able to modify each of these chairs separately. If I'm not in this space, whether I have object blocks or I bring these in, or if they're just simple objects that I've grouped together, we've already learned how to group the chairs separately from the table. I can't modify them, whether they're blocks or groups, but I want to have this capability. I want my object to be smart. I select it and assign the point parameter to it. I assign it, for example, to this object right here. Then I say, let the move action be assigned to this parameter. It says, select your objects. I say just the chair object in this column. Now I can close it, go to the main AutoCAD window to check it, or should I stay here? We said in the block test. As a dedicated and comprehensive place specifically designed for thorough and rigorous testing, here I am fully capable of meticulously testing it. Now, with careful consideration, I am presented with a clear choice. I can either completely change this entire object, which encompasses all its components and characteristics, or I can specifically and separately, with precise focus, modify just this individual chair, addressing its particular attributes. Now here's a crucial and significant point that requires attention and further discussion. When I change the whole object, the move grip related to this chair gets separated. Why is that? Because the first time I defined this point, this spot, I said let this whole object move, or this point, or this move parameter. But the new one I made, well, it wasn't in my selection, so that point didn't exist either. I have to say, bring this one too. Let it move. What do? I will now proceed to create a brand new selection set, and then I will specify that the entirety of the object should be affected by this selection. Now I go to the test block window. Okay, the whole object has changed. If I move it, this point moves along with it and is affected. So you really need to pay close attention to these things. It's possible that in several steps we define actions, and then the actions we selected in the first step. And some objects might not have been selected at all, and some objects might not have been included. So you need to come to the test block window and test them. Now it's very simple. We have created a smart block here with chairs, and now I can apply this to all objects. I could also say again that the chairs, apart from the block itself, can have their positions changed independently. Look. In the end, when they exit the command, even if this object is here, if I try to select them again or move the mouse over it, no matter what I do, it's a single object, but each of its components can be changed separately. Just like that, I can put this object back in its original place, or I can bring in another object to work with. Many objects already have their own base point, so there's no need to define a point or assign the move parameter to it. They already have a handle, which serves as our base point, and we can use it. It's accessible. Now we want to make some edits to this and turn it into a smart block. What we want to do is make its length stretchable so it can be increased. Parameter was one of the sub-options of point, and there was another action that could be assigned to the point. We select the point. We say, for example, this point. Okay, the exclamation mark appeared, saying you need to assign an action to it. It doesn't work just like that, right? So we click on position again. We had move and stretch move, which we already explained. Now we want to explain stretch. I say in the action tab you were already familiar with stretch. It was one of the editors we explained to you before. Let me go back. I select the stretch block editor. It asks, which parameter do you want to assign it to? I say, to this parameter. It says, a frame. You have to drag to indicate which part of the object you want to be affected by the stretch, to be stretched and have its length increased. I say, this cutter. Now it asks, should it select your objects? I say, the objects that are within this area should be affected by the stretch. That means this part stays fixed, and from here to the right it gets stretched, and I click on this end. The element of surprise is gone. That means our stretch action was correctly applied to our parameter, and I click on Block Editor. In the text block section, I could also go and select my object, and a point appeared. Here, I grab this. You see, it stretches in any direction I want. If I press F8, let me hit Ctrl+Z so it becomes exactly horizontal. Then I press F8, and now I can only change it horizontally. I can increase or decrease length 1, depending on what I need. It's really interesting. I can change its position, and I can also change its length with just one click. Of course, having such a long bathtub doesn't really make sense or have any practical use, but it's just an example so that we can fully understand and grasp the capabilities of dynamic or advanced blocks. So that's it for the stretch parameter point section. Now let's take this object and put it back in its place. We'll use another object so we can review the next examples together. We've inserted a piece of furniture or a chair. We talked about the point parameter. The next parameter is linear. How does it assign it to objects? I select it, set a first point and a second point, which determines a distance, and it's fixed here. It's like dimensioning, but it hasn't actually given us a dimension. It's just defined the range. It says, within this range, I've defined a parameter, a linear parameter, which unlike the point parameter is a bit different. It doesn't have a point that can act as a guide for me. It doesn't have a single grip or handle. Instead, it has two handles here, and if I click on it again, this time I can assign 4 actions to it: array, move, scale, and stretch. Let's start with the array action. Oh, can we? I said let's select them and choose array. For example, then it says select the objects, because now it knows it's for this parameter, and I can do my work. I'm saying what if nothing is selected directly and I come in like this? If I go to the action tab and select the array parameter, it asks which parameter you want. Should this action be assigned? I say to this one, then it says now select your objects, and I say I'll select these objects. I click this button at the end, and it says specify a gap between your columns and rows. I say set their spacing, and I also click on gap so that there's this kind of space between them. The action for it. Once it's assigned, I go to the test block section. I select it. There are 2 handles or grips. Now actually I grab these next to them and drag them. This fascinating phenomenon can happen from both sides, specifically from the left and also from the right. It is indeed a really interesting and quite remarkable feature. Now just imagine for a moment I press the familiar Ctrl+Z command. You have brought this particular object in as a cohesive block, for example, an entire airport. Very quickly and with great ease, you can then proceed to make another identical copy of it. Suppose you want to quickly arrange different rows of an airport, like setting up seats very fast in such a space. We've achieved our goal very quickly. So as we said, there are handles on both sides, and we can extend the length from either side. If we click on it again, we enter the block editor window. Here we have 2 grips. We select our parameter. As we mentioned, if we press Ctrl+1 on the keyboard, the parameters and properties window opens, showing the details of that parameter. Here we can see the general section, which layer it's on, the line thickness, the layer name, and now we're on the 0 layer. What's the line thickness? What's the line type? Is it dashed or solid? There are 2 important sections here: value set and misc. In the misc section, I want to point out that you can increase or decrease the number of grips. Right now we have two triangles. What happens if we set it to 0? We save it. Now we have this object, but the 2 triangles are gone. I can no longer make it bigger or smaller. I can't do anything with it. From my perspective as a user, it's hidden. If I select the parameter again and press Ctrl+1 and set the number of grips to 1, only the triangle on the right will appear. I save it. When I select it, I can only increase it from this side. There's no triangle on the other side at all. I've set just 1 grip for it, okay? To enter it, we go in. You really need to pay attention to these things. We select the parameter. There's another important option here, which is currently about the base location. If it's set to start point, it takes the start point as the origin. Here, when we drag from the right, it keeps extending. Another option we have is midpoint. If it's set to midpoint, it takes the middle point. Let me save it so you can see what happens. So when I drag it from both sides, it actually duplicates from both ends. It took the middle as the base, and when I drag from one side, since I only have 1 grip more on the right, it increases from both sides. Depending on our needs, we can use any of these options as needed. Just remember, in the properties window, if you don't want it, you can revert it to the original state. I'll explain the rest of these options, like value sets, in later examples so it doesn't get too confusing for you. So if I set the array parameter to linear, it will only duplicate in one direction, in a straight line. If we want to arrange this object in both length and width, like a cinematic grid, we need to use the XY parameter, which we'll get to and discuss later. For now, I'll close this. I'll put this mobile back in its place. And this time we'll bring this dining table here so we can examine the next parameter together. We have a dining table and we're still working with the linear parameter. Let's assign the parameter to our object. We already talked about the array parameter, and move was very simple. It was for moving objects, which we discussed in the previous section. Now, let's review stretch together here again. I can either click on stretch, or as I've told you many times, we can come and assign the stretch action to a specific parameter. Which parameter should the stretch action be applied to? To the distance. Now it asks you to specify a point so that it can place a triangle for you, and from that point you can grab and stretch it to make it smaller or larger. By default, it uses the start point and the second point, meaning the first point here or the second point. I can also choose any other place I want. For example, even outside the object, it doesn't matter at all. I'll set it to the second point right here. Now it says specify a range. I say here because I want to stretch it to the right from here. It asks you to select your objects. I select the objects that are within this range, and then I press enter. The stretch parameter is now assigned to this point and this distance parameter. Well, we said that whenever we assign an action to our parameter, the yellow exclamation mark disappears. So why is it still here? Because we had two grips, two handles. We only assigned an action to one of them. We can assign it to the other one as well if we need to. If not, we select the parameter, press Ctrl+1, and in the properties section under MISC, we set the number of grips to 1 and close it. Now we only have the right handle, and we do not deal with the left one anymore. We click Close Block Editor, Save, and when we select the object, we have a tool for moving it, and there is also a triangle here. You can easily drag it to change the length of the table. From a round table for 4 people, it can become a table for 6, 8, 12, or even 24 people. But the sizing is manual. I'm changing it by hand and approximately. Notice that the angle is always perpendicular. Even if F8 is turned off, I'm only moving my hand linearly up and down in all directions, but it doesn't change at all. It's only linear. What's the difference between this and the stretch we had in point mode? We could change the scale in all directions, or scale the whole thing, even though it would get deformed and was not really useful for us, but still, we could move it around. Here, because the parameter is linear, it is only in the lengthwise or horizontal direction that we can increase the length for the table. Now, look, I could resize my table without any limitations, using arbitrary numbers, whereas in reality, we should have a standard. For example, tables have architectural standards, and every product has its own standard or catalog. For instance, this table might be available in the market in just a few limited lengths. Now, let us say I want to set my table's length to about 150 to 160, but when I try to set it exactly to 150, it does not come out precisely. Then, say the next size is 250, and I want to set it to 250. I can type in my approximate number or value. For example, set it to 250 for a moment, then if I want it to be 400, I have to type 400 and press enter again. But there is something I can do to make this process easier. How? I select it, and for the lengths I want to set some restrictions. I want to say, for example, you can only change it at 1 meter, 2 meters, 4 meters, and 8 meters, not allowed to change the parameter at say 5 meters. I select the parameter, press Ctrl+1, and its value set type is currently none. Well, I can set it to increment or to list. If I set it to increment, I can specify, for example, increments of 50 units, or to make it clearer, increments of 100 units. You can't change the length by more than that each time. The minimum distance, for example, can be 200, and the maximum can be 1000. These numbers are just examples, so we can learn. Now let's close this. You see, a series of distinct lines has now appeared here. I will proceed to click Save. Now, when I carefully select this particular object of mine, I'm only allowed to change the length within these ranges. If I try to set it between these two, it won't work. It has to be either this way or that way. It can't go higher or lower, as you can see. This made my work much simpler. I imported a table. I also know its exact dimensions and measurements. Quickly. It can be this size, or this size. Now there's another mode as well. We go back into the block editor, we select the parameter, we press Ctrl+1. Instead of increment, I set it to list. After this, in the window, I can define a list and assign dimensions to it. For example, I can say add the number 100, 200, 300. I set it so that this table only has 3 sizes, and that's it. I close this. Now let's see what happened. I select it, and it only has 3 sizes now, plus the initial size it already had, which was here. 265, 100, 200, 300. I can also choose from the list which size it should have. So that's how the stretch action works for the linear parameter. We place it where it belongs. I'll make its length a bit shorter so it fits here. Let's move on to the next object. We have a carpet object. With this object, we want to check the next parameter and action. We're still on the linear subparameter. First, I assign a parameter to the carpet we have. We said that if we select a parameter, array, move, scale, and stretch move, which we checked at the very beginning for the point. Array and stretch we already reviewed. Now we want to check scale. It's also in the actions. I select the scale action and it asks me to choose the parameter. I assign it to this parameter. Now it asks me to select the objects. So I select all the objects and hit this button at the end. Now I close it and I can also see it in the test block area. It doesn't make a difference. The reason I usually don't go into the test block is because since I'm recording the screen, I think maybe if the background is darker, it will be easier to see. But ideally, we should test this in the test block. Now I select it. I can easily scale it, and this can happen from both sides. I close my test block and select distance. I press Ctrl 1, so I can set its grip to just one side so it only scales from one direction. I go into the test block. I select it. I can scale it from one side. Now if I wanted to use the scale parameter, the block wasn't smart either. I select scale. I set a base point for it. I scale it. Again, if I see it's not correct, I select the object. Scale, base point. Now I enter the size again. Or its scale factor, its scale multiplier, but here it's easy to make it bigger or smaller with just one button. Now imagine we have a house and we've imported a carpet object. We want it in 3 sizes, for the living room, for the bedroom, and maybe a small rug, a runner for the hallway. These rugs, like tables and other things, don't come in every size we want. They need to have a standard size. I'll close the test block. What I want to say is, let's have a limitation for this scale. Let's only have 3 sizes. I select the parameter, press Ctrl +1, and from value set, I set it to list. In this window, I delete this value so that it has 3 numbers. Let's set them 200 and, for example, 400. Let's say 3 distinctly different sizes. I will select these, then delete them, and I can also meticulously enter my numerical values in another convenient way. 100, 200, and 400. Now, if I simply press enter or the add button, they all come down together quite smoothly. I will click OK, and my specified values are then successfully added. Now, there was also a default value that was previously set. I'll proceed to close this particular window. Let's now move on to the test block. This scaling process happens in 3 distinct sizes. 100, 200, and 400. Okay, I will now close my block, and then I will thoroughly test my block, and I will also close the block editor. Now the object that I've carefully placed within the scene, I can very quickly and efficiently set it in many different sizes for various purposes, such as first, I make 3 copies of it. Imagine I've brought my object into the scene. Now I can set the sizes. I'll use one for the living room, the second one, for example, for the bedroom in this size, and the third one is going to be a small rug, and for the hallway. So, very quickly I was able to use 3 different carpet sizes. So that covers the linear parameter. We've explained all its aspects. Now let's move on to the next parameter. Again, we'll use our table object for this. We click again and enter the block editor window. The next parameter we have is the polar parameter. The polar parameter is similar to the linear one, but it can change in directions other than the horizontal direction. I'm going to delete this parameter. I'll assign the polar parameter. I select it. To get rid of this symbol, I'll set its grip to 1. The point is, you don't have to create your smart blocks from scratch every time in every project. I'm teaching you how to make your smart blocks once and for all, so you can use them in your projects forever or edit those same ones. Now, if I select it, you'll see there are 5 items: array, move, scale, And we've already covered stretch. Only polar stretch is new. You can see in the actions, polar stretch is here. We select it and assign it to the parameter. It asks from which point our polar stretch should start. Let's say from here, where my triangle is. We define the range, then select the objects, press enter. After pressing enter, it asks, now I'm stretching it from this part, but in polar stretch, the object can rotate. At what angle do you want the object to be placed for the stretch? On the table, we can't just rotate this one piece. The whole table has to rotate together. So I select all the objects and press enter. The command is now fully completed. I save it. Now, I have an object here. This one is for moving it. Well, here instead of a triangle, it shows a square, which indicates polar stretch. I can move it in any direction I want. I can increase its length and rotate it. For a simple stretch in linear mode, I could not do that, but with the polar parameter and the polar stretch action, I can both increase its length, and if I press F8, it will behave exactly like it will act like linear stretch. So that is it for polar stretch. To explain the next parameter, we're going to use a cinema chair as an example. Now let's enter the block editor. The next parameter is the XY parameter, which we're going to talk about together. The X and Y parameters are defined along the horizontal and vertical directions, the X and Y axes. We can set parameters for these axes. I select this parameter, set the base point here. This is the X direction and this is the Y direction. Notice, I haven't clicked yet. I've just set the base point. The X and Y are like two linear parameters, horizontal and vertical, given to me at the same time. But here, there are 4 grips for me on the parameter. If I double click on the parameter, I can actually assign different actions to it. We want to select the array parameter, so we use the array action and assign it to this parameter. It asks you to select your objects. These are our objects, and I press enter. Now it asks to specify the distance between the rows, so I say, for example, let it be this much. Now both horizontally and vertically, we draw it roughly. Later we can adjust it to make the spacing precise. If we wanted it to be even more precise, we could have started from this corner. For now, let's say it's done here, and the action is assigned to this parameter. Let's do it together one more time so you understand it well. I'll delete it, the parameter. The XY action, which is a crucial step in this process, asks you to carefully select your desired objects. We then proceed to press the Enter key, and now the system prompts you to precisely specify the exact distance between your individual cells. I would say, from this particular point, a bit larger than the actual physical size of my chair. Subsequently, the array is then automatically assigned to this specific XY parameter. Finally, I will save it, ensuring all changes are preserved. Now I also have 4 grips. And then I can, as you see, please arrange and duplicate these chairs in a visually appealing and cinematic way. Now just imagine for a moment, we've successfully imported an object and then brought it into our scene as a distinct block. Very quickly and efficiently, we can then arrange the chairs for a cinema or perhaps an amphitheater with it. This time, we will set the distance manually, ensuring precise placement. Whoa. How can we set a more precise distance? We select the action. We press Ctrl+1. Here we can specify the row offset and column offset. We can set it in the X direction or for the horizontal rows. For example, let's have a distance of 50 units. And for the vertical rows, 100 units, so that people can easily pass between the chairs. We close this, we save it. We select the object. Now before that, let me fix the number of grips as well. When we select the parameter here, the number of grips is 4 by default, but we set it to 1. As for the value set, which you already know, you can set minimum and maximum limits or put it on a list or increment. Basically, assign specific values to it. Since we've already covered these, we won't go over them again. You know them well. The grips should be set to just 1, and when we select it, we only have 1 grip, which is this one. But when I duplicate it, you can see the intervals are 50 centimeters and 100 centimeters. I can duplicate these at any value I want. So that's it for the XY parameter, which had different sections. I'll delete its action. Its various parts were array, move, scale, and stretch. Move, scale, and stretch are similar to the previous modes. There's no significant difference. The only difference is that, unlike the linear mode, the movement here is in two directions. I wanted to share that with you and review it. Now, we'll exit this parameter as well. The last topic we'll cover in this session is the rotation parameter. I'll bring in a compass symbol that's commonly used in various maps. We want to rotate this, so we need to use the rotation parameter. We select the rotation parameter, and it asks us to set a base point for it. I'll choose the center, then it asks for its scale, and I'll set it to match the size of the compass itself. And now for the rotation angle, I say, well, I want it to rotate 360 degrees. That's it. Then I click on the base point as well. Next, it asks where the label itself should rotate, or, in fact, where it should be placed. I say, right here. The yellow exclamation mark needs to be assigned an action. We assign the rotate action to it, so that the rotation is assigned to this parameter. It asks you to select your objects. We say these objects, making sure all the objects are selected, and then we press enter. Now look, by grabbing this circular point, I can easily rotate my object to virtually any angle I desire. But just like other modes, I might want to do this only at a specific angle. Now I think you can easily guess how we do this. We select the parameter. We press Ctrl+1. We set the angle type to list. We give it a list. We say angle 0. 30, 60, 90, 120, 150, 180. Okay? We save it. Now I can only rotate my object at these angles. It won't rotate beyond that. And it won't even stop at values in between. 0, 30, 60, 90. And I've set a limitation for it. This is a smart block. Very simple. Let's select it again. Select the parameter, Ctrl+1. As I said for review, we can just set it to increment. For example, we can clearly say that it demonstrably increases by exactly 21 units each and every time. This progression spans from an initial value of 0 all the way up to a final value of 360 as well. I select my specific object so that it can functionally rotate. Let me zoom in so you can see better. 20, 40, 60, 80, 100. And it can rotate fully up to 360. You can use this feature at different angles. Alright, we'll go over the rest of the parameters and actions in future sessions with more detailed examples. I hope you enjoyed this session as well. Until the next tutorial, goodbye.